Chapter 4, Problem 6. A box which has a mass of 90.8 kilograms is at rest on a rough horizontal floor. A man pushes on the box with a horizontal force of 376 newtons. As soon as the box begins to move, a friction force of 214 newtons acts on the box from the floor. A. What is the acceleration of the box while the man is pushing it? So first make a list of the forces. So we have Fg, we have a friction force, the man is pushing, let's call it F, and finally the floor is reacting to the pressure that it feels, and that reaction is called Fn, the normal force. The next step is to draw a free body diagram. We cannot know the exact length of the arrows, but we can estimate them. Fg is roughly the mass times 10, so it's roughly 908 newtons. In this case, the only force that is pressing downward is Fg, so Fn is reacting to Fg only. Therefore, Fn has the same magnitude as Fg. And finally, we can draw F, which is roughly 400 newtons, which is a bit less than half of Fg. And then the friction force is roughly 200 newtons, which is roughly half the size of capital F. Now, just by looking at this free body diagram, I can tell that the acceleration is to the right. Fn and Fg balance out, and F is larger than the friction force. So I can draw an acceleration vector to the right. Since the object is starting from rest, so the initial velocity is 0, it will be set in motion and will eventually move to the right. So the velocity will also be to the right. Let's start the calculations now. So the first principle is Newton's second law. The sum of the forces is equal to the mass times the acceleration. Now, I cannot use it in that format unless I'm really good at using I hat and j hat. Well, actually, let's try doing it that way. So, Fn, using I hat and j hat, Fn is going to be the same as the opposite of Fg. So first I need to calculate Fg, which is m times g times j hat with a negative in front because it's down. So negative 90.8 kilograms times 9.81 meters per second squared j hat, which is equal to negative 891 newtons j hat. Fn is equal to the opposite of Fg, so it's going to be 891 newton j hat. Next we have F, which is 376 newtons I hat, and the friction force, which is negative 214 newtons I hat. If I add all those forces together, that is Fg plus Fn plus F plus friction, what I notice is that those two cancel out. So next time, in order to be faster, what I could do, I could just skip that step because I don't need those numbers. And so I'm left with 376 newtons minus 240 newtons times I hat, which is equal to 162 newtons to the right. Now going back to my first principle, sum of the forces is equal to m times a. Therefore, a is the sum of the forces divided by the mass, which is 162 newtons I hat divided by 90.8, which gives me 1.78 meters per second squared I hat. So this is the method using I hat and j hat. It's really fast and it gives you the full answer in vector form. Now I'm going to use another method that is making use of the two axes, the x and the y axis. So the first step is to add an x-axis and a y-axis to your drawing to define them. And then now you can work using components. So Fn is 0 along the x-axis, and it's going to be m times g along the y-axis. Fg is 0 along the x-axis and negative m times g along the y-axis. F is 0 along the y-axis and 376 newtons along the x-axis. Finally, friction is negative 214 newtons and 0. So what you can do now is you can apply Newton's second law to each axis. Along the y-axis, you get 0 equals mass times acceleration, which tells you that the object is not accelerating in the vertical direction. Along the x-axis, you get 376 minus 214 is equal to the mass, which is 90.8 kilograms, times the acceleration. Actually, I should add the unit over here, newtons. You solve for ax, and you obtain 1.78 meters per second squared. Now, if you look at those two components, you can conclude that the acceleration is 1.78 meters per second squared I hat.